Hi, I'm Mike Barsick, Director of Technical Services at Southface. Duct leakage testing equipment has long been used in the home performance, green building, and weatherization industries to improve the performance of duct systems in existing homes. This equipment is also used to verify that certain energy code requirements are met. We're going to walk you through a step-by-step demonstration of the duct leakage test. This test builds on the knowledge and skills taught in the blower door video. Please review the blower door video before watching this video. You can access the blower door video by logging on to southface.org. Duct leakage is often the single biggest waste of energy in a home. Duct leakage testing is used to quantify the amount of leakage in a home's duct system. Because conditioned air can leak out or unconditioned air can be pulled in, it is important that these holes be sealed in order to save homeowners money and reduce pollutants from entering the home. There are two types of duct leakage tests: total leakage and leakage to the outside. Total leakage quantifies the total amount of conditioned air that leaves the duct system into both conditioned spaces, like living rooms, and unconditioned spaces, like attics, crawl spaces, and garages. Leakage to the outside quantifies only the amount of duct leakage leaving the building envelope. This duct leakage is lost into the unconditioned spaces where the ducts are located. Let's go over the equipment we will need and run through a checklist to make sure we have everything. You will need the following: a grill adapter, flexible transition duct, tubes, fan, and gauge. You will also need duct mask and masking tape. Finally, you will need all of the blower door equipment and a smoke stick to help find duct leaks. There are several companies that sell duct leakage test equipment. The equipment we are using in our demonstration is from Energy Conservatory and is called a duct blaster. The duct fan and gauge are calibrated so that duct leakage is measured accurately. After the equipment is purchased, it is important it is properly maintained so that it remains calibrated before you begin any testing. There are two types of tests you can run: a pressurization test and a depressurization test. In this video, we will be demonstrating the pressurization test. This is the most common way to measure duct leakage as it requires less equipment. It is important to set up the house properly to make sure the test is accurate. To set up the home, turn off all fans in the home, including the air handler. Temporarily tape all registers, remove the air filter, and attach the grill adapter of the duct blower to a centralized return. Seal off any remaining openings of the return grill with tape. Snap on the flexible transition duct or duct trunk using the Velcro strap and extend the duct trunk to its full length so that it is as straight as possible. The duct blaster comes with 3 rings to best match the needed fan flow. Correct installation of the flow ring is important for test accuracy. Select an appropriate ring to test your duct system. Leaky duct systems may require you to use open fan, whereas tight duct systems will require you to use ring 3. For this test, we will use ring 3. Pay special attention to the military connector as the fan control has 4 holes with only 3 connections and 3 pins. Once the duct blaster is in place, you will set up the gauge. The digital gauge has 2 sides and each side is a separate pressure gauge. Each pressure gauge measures the pressure difference between 2 taps. The A side will measure the pressure difference between the duct system and the house. To measure the pressure of the duct system, attach the green tube to the upper input tap on side A of the gauge. The other end of the green tube will run to a supply register. The lower reference tap needs to remain open to the house. Open a window or door and the pressure of the house will be equal to the outside. The B side of the gauge will measure the pressure difference across the fan with reference to the fan inlet side. In this case, the house. Connect a red tube from the fan to the upper input tap of side B of the gauge. The lower reference tap needs to remain open to the house. Since side B of the digital gauge measures fan pressure. It can be programmed to calculate the CFM passing through the fan. To program the gauge for the total leakage test, press the Mode button 3 times so that it displays pressure and flow at 25, PR/FL at 25. Press the Device button 4 times to select DBB, or Duct Blower Series B. Press the Config button to select the appropriate ring on the gauge, such as A1, B2, or C3. Now you are ready to test your duct system. To measure total leakage of the duct system, use the duct blaster to pressurize the duct system to 25 pascals, a typical pressure the duct system experiences when the air handler is operating. The right-hand side of the gauge will then display the flow required to obtain this test pressure. This will be the CFM 25. In order to compare this number across multiple building types, many programs require you to normalize duct leakage according to the size of the home or HVAC system. For this example, we will compare duct leakage to the floor area of the zone it serves. The percent duct leakage is determined by dividing the CFM 25 by the conditioned floor area that is served by that system. In this home, for example, the first floor area corresponds to System 1 and the second floor corresponds to System 2. Since we are testing System 1, we divide CFM 25 by the area on the first floor. We then multiply by 100 to determine the total percentage duct leakage. Now let's measure the leakage to the outside. With the blower door in place, flip the fan flow switch, or if your fan does not have a flow reversal switch, turn the fan around and pressurize the home to 25 pascals with reference to the outside. Because the ducts are considered part of the building envelope, they should read the same pressure as the home. However, ductwork leaks, and the pressure in the duct system will usually be lower than the pressure inside the home. With the blower door pressurizing the house to 25 pascals, turn on the duct blaster to pressurize the ductwork until the pressure difference between the ducts and the home reads 0 pascals. Because the blower door is pressurizing the house to 25 pascals, and the pressure difference between the ducts and the house is 0, the ducts are effectively the same pressure of 25 pascals. The resulting CFM 25 found on the right-hand side of the gauge represents the leakage to the outside of the envelope. This value will be used to calculate the percent duct leakage. If the duct system is not up to par, we can leave the duct blaster running and use a smoke stick to find leaks in the ductwork. Once you have determined your results, compare them against the Energy Code or Green Building Program requirements that you are hoping to certify under. A visual inspection of the duct system can go a long way in explaining test results. Pressure pans can also be used with a blower door to help locate which duct runs have the most leaks. And finally, a theatrical fog machine can be used in conjunction with a duct blaster to identify problem areas. Studies indicate that as much as 25% of total house energy loss can result from duct leakage. Duct leakage can also result in poor comfort levels in the home as well as indoor air quality problems. By learning how to quantify and locate duct leakage, we hope you will not only improve the performance of the home, but also the comfort and health of the occupants.